All right, guys. Continuing with our box method, today I'm not even going to put binomials in there. Everything's going to be bigger than a binomial, especially tonight's homework. On tonight's homework, I want you to be very, very careful with all of your numbers. And remember, when we're filling in the box, we're doing multiplying. And then when we're pulling out of the box, we got to switch gears a little bit and we're going to be doing adding. To help you prepare for tonight's homework, I'm going to be multiplying a trinomial times a trinomial today. So remember that terms are separated by adding and subtracting signs. So as you're looking through the problem and you're trying to determine how many terms something has, you want to take a break everywhere you see adding or subtracting. So in our first parentheses, x squared is a term, 2x is another term, and 7 is our third term. And then in our second parentheses, the 2x squared is one unit because it doesn't have adding or subtracting between it. So it's one thing. The 3x is also one unit. And then the 4 is my third term. Now, since this is a 3 by 3 box and both sides have 3 terms and everything is nice and equal, it doesn't matter which parentheses you put along which side. So I'm going to switch it up a little bit this time. I'm going to put that second parentheses down the left-hand side because it doesn't matter. And I'm going to put the first parentheses across the top. As long as you're keeping the parentheses grouped on the same side, it doesn't matter which side they're on. So we can't mix and match. You can't like swap the 4 and the 7. Okay, now we multiply. So 2x squared times x squared. I'm going to add my exponents. 2 plus 2 is 4. Now, if I'm doing this correctly, I can already kind of guess what my exponents are going to be for the rest of, actually for the whole rest of the problem, right? If this is x to the fourth, next to it should be an x to the third and an x squared. Same thing going down. X to the fourth up here, this should be an x to the third and an x squared. So that's how you can check and see if you're doing your exponents correctly. I'm going to keep going across that top row. So next I'll do 2x squared times 2x. So the 2 times 2 is 4 for the front. And then x squared times x to the first is x to the third. 2 plus an invisible 1 is 3. To finish off that top row, I'm going to do 2x squared times 7. So 2 times 7 is 14, and I keep my x squared. Again, notice descending order, okay? Moving down to my second row, 3x times x squared is 3x to the third, descending order. 3x times 2x is 6x squared, and 3x times 7 is 21x. Moving to my final row, 4 times x squared is 4x squared. Look at that, x to the fourth, x to the third, x squared. Exactly what I was expecting to happen. 4 times 2x is 8x, and 4 times 7 is 28. Okay, now this is a larger box, but we're still going to find our like terms on the diagonal, and our first term will still be in that top left corner, and our last term will still be in the bottom right corner. So same concept as before, just more numbers. My first set of like terms are the x to the thirds. And remember, we're adding, so we add our coefficients only. 3 plus 4 is 7. And we keep the x to the third. Now for my next diagonal, it actually got a little bit longer because we added that third row. So for my x squares, I'm actually going to add together 3 boxes. 4x squared, 6x squared, and 14x squared. Now remember, you're just adding the coefficients. So I'm going to do, what do we got? 4 plus 6 is 10, and 10 plus 14 is 24. And I keep the x squared the same. So we're not changing our variables, just add the coefficients. My next set of like terms will be the 8x and the 21x. And 8 plus 21 is 29. And then the 28 does not have a like term. So your first term and your last term, they won't have like terms, but everything in the middle should have like terms. We snake our way around, and our final answer for this problem, 2x to the fourth plus 7x to the third plus 24x squared plus 29x plus 28. So on tonight's homework, make sure that you're making your box the correct size based on how many terms there are. And remember to go across the entire diagonal, adding all of the coefficients together, but not changing your exponents. This concludes our video for today.